I think we can start today's session. Welcome everyone to seventh session for the subject strategies for sustainable design. This will be week 7 of your lectures. We'll be doing assignment 7. So, this assignment is actually not the one which you are assigned in the current run. This assignment, which I'll be sharing with you, this will be the assignment which was assigned in the previous run of this subject. So the question which I'll be discussing in this live session, it might differ from the ones that you are assigned currently. However, the questions pertain to the same subject matter that you have covered this week. So I hope solving similar questions or solving questions which relate to the same background study can help you solve your questions better and can even help you further prepare for uh, your upcoming exams and how you can approach the questions in the final exams and so on. So, in week 7, you would have covered the following two lectures. First is the National Building Code 2016, not the whole code, but part 11 of the code, which is related to the Energy Conservation Building Code or ECBC, you know. So you would have studied a little bit about the National Building Code, what it is, what are the new updates that have been added to the 2016 edition, and a little bit about the sensitivity of this code to the Indian context, as we study energy efficiency or green buildings or energy efficiencies in buildings. We study a lot of building codes and standards which are internationally accepted, but many a times they fail to incorporate the Indian context into it. So, because India has a different socio-economic system and even climate as compared to the other countries globally, so it is important to have a building code or standards which are sensitive to Indian context so that they can uh, incorporate the concerns of Indian buildings and how uh, energy efficiency can be managed in the Indian context. Okay. The next thing which you would have studied uh, would be the uh, Griha guidelines. So, Griha guidelines are guidelines for building design, or actually, they are sort of a rating system which guide you to how uh, any building construction or any building design and construction can be formulated in a way that uh, the building can follow a green building standard. I'm sorry, I forgot to ask if I'm audible to everyone and if you all can see my screen. If anyone can just quickly indicate. You can, any one of you can just write in the chat box and you can indicate. Okay, Bushra is saying yes, so I hope I'm audible and my screen is visible to everyone. Thank you. So we'll move forward now. So this is what you would have studied for Griha. So we'll move on to the question. So this is a subjective question which was assigned in the previous run. I am aware that in this run you are assigned objective questions, multiple choice type questions. So this question is very different from the one which you are currently assigned. But this is the question which was assigned in the previous run. So I'll be solving this question for you. So the question basically asks you to analyze and score your residence as per the Griha guidelines, and it gives you the format of the guidelines or the self-evaluation checklist, which you can follow to analyze and score the your score the score of your residents as per the guidelines. So before moving on to the Griha guidelines or the evaluation checklist, let's see a little bit background on the green building systems and the Griha rating. This is just a short catch up on the subject matter for ones who might need a refresher on this or who might have missed a few key points while going through the lectures. So first let's talk about green building rating systems. So what green buildings are? So you would have seen in the previous lectures also that the way we consider buildings smart or we consider them uh, or sustainable or we consider them energy efficient, we consider buildings to be green, uh, we consider them to have socioeconomic value, we associate them with good quality of life and so many other things. So there are several different parameters on how you can uh, evaluate if a building is intelligent or is it smart, is it green, is it livable. There are several different things. So this is the basic flow chart which you would have studied on the classification of the various terms we use, because many times people confuse, is a green building the same as sustainable building, is sustainable the same as energy efficient building, is it the same as a smart building. There are a lot of overlaps many a times among these terms, but if you really want to classify all of the different terms and focus on what each means, so you can follow this classification. So if you're focusing on sustainability or intelligence of buildings or even larger habitats like urban areas, cities as such, if you're focusing on digital part of the building or introducing information and communication technologies to make the building more sustainable, then you can call that to be smart. If you are using some type of uh, Intel or web-based service, you can again classify it under smart. Then if you are considering livability or quality of life, it falls under the social parameter of sustainability. Same is for sentience, when you take into consideration even the sensory parts of sustainability of buildings and cities, again it falls under the social umbrella. If you focus on the livability, so things like livability index and such, so that again falls under uh, social umbrella. But it also again then falls under the environment umbrella as well, because livability is not just social or the people, it's not just concerned with the people who are part of that system, so either building or city, but even the environment surrounding it becomes a part of that equation when we talk about livability. When we talk about green, so green buildings or things like that, it focuses largely on the uh, environmental concerns related to the sustainability of buildings. Same as nature or uh, buildings which we consider are close to nature or respectful of nature, or they focus on the natural context of the environment. So these are the different classification terms related to the sustainability and intelligence of building and cities. Of this, the one which we are focusing on today is the green building. So green building is basically the practice of creating structures, so buildings or even larger structures like habitats and cities, So it is the practice of creating structures and using processes that are environmentally responsible. So we are not talking here about ICT or web-based services or quality of life or introducing some smart technology into it, but we are largely focusing on environment responsibility aspect of sustainability when we talk of green building. And this can range from site design to construction to operation and maintenance of the building to then further renovation or even deconstruction of the building. So this is what the concept of green building is. So in order to actually identify which of the buildings can be considered green buildings, there are several rating systems which are existing currently and which are followed by different countries. So these rating systems are known as the green building rating systems. These are basically a set of prerequisites and requirements which any building or any city or any other project needs to fulfill in order to receive that certification that okay, this building or this project or this city is green. So that is what basically a green building rating system is. So there are several different rating systems as I just said. So for example, there is BREEAM, it is for United Kingdoms. Then many of you must have heard about the LEED. It is for the United States. Then for Canada there is Green Globes. Australia there is Green Star. Hong Kong there is BEAM. Taiwan there is EEWH. South Korea they have GBCS. Japan have CASB, and for India we are currently following the GRIHA. So what I have done here is that GRIHA will be going uh, going through in detail further, so you don't need to worry about that. But other rating systems apart from GRIHA, if you want to see how other rating systems evaluate their green buildings or their green projects, or how they evaluate, how they check performance, what indicators they use, how they measure, and what is their system of measuring and keeping records and providing certifications. If you want any of that information, I have provided links to each of the rating system that I have mentioned here. For example, this is the UK one. So you can just click on to the link and go to their website. So this is their uh, this is their website for the rating system. So you can see they have several different evaluation criteria similar to GRIHA. GRIHA these days also have several different evaluation toolkits and associated uh, checklists. So for example, there is a net zero carbon one, there is a whole life performance one, then how uh, health and social impact, health and society are impacted by the particular project or a building, then about circularity and resilience, about the biodiversity, and then about disclosures and reporting. So you'll always see that most of the times the different rating systems, they have their own different criteria of rating the buildings. They have their own different indicators, and many a times they have some special or some unique way of evaluating or rating something which Griha might not have. So if you want to see further that how different systems evaluate their how different countries evaluate their green buildings or their project to be green, you can visit the different links. For example, you can see this is their net zero one. So they mention how you can achieve net zero building. They do not provide detailed information here, but you can see maybe in their products. There might be some uh, manual or some information brochure which you can browse and you can get more information. Similarly, there is LEED for United States. So this is the LEED rating system. So you can see how the LEED works. So like GRIA, we have star rating system, so 1, 2, 3, 4, 5 stars. LEED has a different system, so it is again based on points similar to GRIHA, but their points correspond to uh, different kind of indicator to show how well a building is doing in terms of being a green building. So like we have stars, they have platinum, gold, silver, and certified criteria for certification of different buildings. So you can see platinum is if the building or project has 80 plus points, gold is 60 to 79 points, and similarly. You can even see the LEED system goals, and you can even find different case studies. So you can just click on to the various case studies and see how they have evaluated different case studies. And this is for buildings, interior designs also, then for operation and maintenance, then for whole neighborhood development. As I just mentioned, that these green ratings, it can be for a building also, and it can be for larger projects or even for cities also, as you can see here. If you want to learn more about uh, lead leads way of certification for green buildings, you can see more uh, more on their website. So you can even access their resources, and you can see their case studies as well. Okay. So similarly, there is a link for Green Globes Canada, uh, for Australia, Hong Kong, Taiwan, and other places which I have mentioned. Also, if you want to read more about how if you want to read more about how sustainability and different terms related to sustainability are classified, I have also linked uh, this classification of terms paper here, which you can go and this is actually a book about intelligent buildings and how intelligent and energy efficient and different terms are classified. So if you want to read more about that, you can go on ahead and visit this link as well. Okay, coming back. So, as I said, there are several different rating systems through around the world used by different countries to suit their specific context. Today we are discussing for this question, we are discussing GRIHA, which is the Green Building Rating System for Indian context. So, what GRIHA stands for is basically Green Rating for Integrated Habitat Assessment. So, habitats, that means buildings or other larger systems, as I said, neighborhoods or even cities. Habitats throughout their life cycle from the start of their planning, designing, construction to then operation and then towards the end of their life cycle, that is demolition, they consume a lot of resources. So these are in the form of energy in or water or the uh, materials they use for their construction and things, and then they also emit a lot of waste. So it can either be in the form of municipal waste, so for example sewage or wastewater or solid waste, or it can even be seen as emissions. Uh, so that can also be considered a waste that building or a habitat is producing. So Kriha is a tool basically that helps the performance of a building throughout this life cycle. So from starting from design to then construction and then throughout its operation and after its demolition also. So Griha assesses the whole performance of the building throughout this life cycle, and then uh, uh, it assesses this performance against a nationally acceptable benchmark. So it basically evaluates the environmental performance of the building holistically over its entire life cycle, and thus it provides a definitive standard of what a green building is. So green building which is responsive to the environment around it. So this rating system is based on accepted energy and environmental principles, as I just mentioned, that it assesses the building against nationally acceptable benchmarks. So the benchmark which Griha uses, it comes from other nationally accepted standards, so which it borrows from to create this assessment system or rating system. So it is based on accepted energy and environmental principle, and it seeks to strike a balance between established practices and the emerging new concepts, both on the national and international level. So Griha basically comes from a Sanskrit word meaning abode. So it reflects abode, that means habitat or a home or a place where people reside. So for buildings or other places which are inhabited by humans, and because it assesses the uh, greenness of such habitats, and it does it in the context of Indian systems or Indian ethos. That is why it is named as such. Uh, it stands for credibility, integrity, and inclusiveness, while also upholding the Indian ethos for future ready and sustainable habitat. So, as I just said, that GRIA measures or evaluates the performance of a habitat or a home or a building or anything throughout its life cycle. So, it takes into account different parts of the whole building's life cycle. So, for example, uh, so as it takes into account the different parts of the building's life cycle, it takes into account the different components of that life cycle, and different parts of the Griha rating or different components of the Griha rating or the indicators. They correspond to different parts of this building life cycle or the components related to the building's life cycle. So this figure here, it represents what percentage of the points which are awarded in the Griha rating, uh, what percentage of point focus on which concept. So for example, you can see 4% focuses on the construction management. So as I said, it focuses on different parts. So it focuses on construction part as well. So 4% is on construction management, 12% is on sustainable site planning, 7% is on performance metering and monitoring, then 8% is on socio-economic strategies that the building follows or takes up. Then 5% is for life cycle costing, 12% is for sustainable building materials that have been used in the project, 6% is for solid waste management, 16% is for water management, 12% is for occupant comfort, so it relates to the occupancy and operation of the building, and 18% is for the energy optimization. So this also uh, is relevant for building operation and management period. So based on that, points are awarded to different buildings. Points are awarded to different buildings or different habitats. which are being evaluated or which are being studied uh, for the certification. And based on the points that these buildings earn, they are provided a rating. So the buildings which have earned points between 25 to 40 points, they get a 1-star rating. Buildings which have more than 40 points and up to 55 points, they get a 2-star rating. Buildings with more than 55 points and up to 70, they get a 3-star rating. Then projects with more than 70 and up to 85, they get a 4-star rating. And then 86 or more points can get you 5-star rating for your project. So this is how Griha rating is divided. If you want to see more about this rating, I have provided the link here. So this is the link to the Griha website. You can see here that different rating variants of Griha are provided here. You are also provided with different case studies. So you can see here. So this is for uh, Cancer Research Institute. This is for an office building. This is for residential buildings. This is for a cyber park. So many case studies are there, and they have range from 5-star to 3-star to different kinds of ratings. So if you want to see how they have been rated or what key factors have been considered while rating them, you can visit this website and see for yourself. You can also see the different certification programs which are there with Griha, and the different rating systems which Griha has now accepted. So as you might have studied in the lectures that from just being Griha green rating system, now there are several different variants of the rating. So there is a Swagriha also now, which is a self-evaluation system which anyone can follow to self-evaluate their home or their project or their building if it is how green it is. Then there are pre-certification ratings as well. Then there are separate uh, ratings for affordable housing. Then there is a rating for an existing building also, so it won't take into the consideration the site and related uh, components of the building life cycle, but it will take into consideration the existing building and up until the building is demolished, or the life cycle of the building from existing to the end. Then there are Griha ratings for day schools also and for large developments. And now there is Griha ratings for cities as well. So these are the different ratings which are available. So if you want to read further or go and see on your own, you can just click on this link and visit the website and see for yourself. So what basically the Griha rating does, or what basically it wants to achieve, is two major goals. First is to reduce resource consumption and greenhouse gas emission, and then next is to enhance the use of renewable and recycled resources in the building sector. So these are the overall objectives which have been focused on by the Griha rating, or the green building rating system, which has been developed by TERI. I think a lot of you might know about TERI. So TERI refers to the Energy and Resource Institute. It is a research institute based in New Delhi, and it specializes in the fields of energy, environment, and sustainable development. So it is a multi-dimensional organization, and it has enormous capacities, and not only in terms of research, but also in terms of policy, consultancy, and implementation of such kinds of projects. So TERI has been an organization which has played a crucial role in bringing about these objectives of resource consumption and greenhouse gas reduction, and uh, use of renewable and recycled resources for the building sector together, and they have converged this and various other initiatives to then create the Griha rating system for mainstreaming sustainable habitats in India. So, what mainstreaming basically means is that there are a lot of environmental concerns or priorities uh, related to building construction or other environmental aspects of habitats. But in order to bring those concerns or get those concerns out into the building sector, or making it available in a way that the different uh, actors of the building sector or the consumer can actually access the knowledge and information regarding these sustainability objectives, and can actually incorporate these objectives in actual building construction. So enabling such kind of process is basically known as mainstreaming. And Griha rating, or rating the buildings, or providing a toolkit or a handbook or brochures for rating, and providing a system uh, for these ratings, providing training and all those things. These count as part of mainstreaming this sustainability aspects into habitats in India, and that is what TERI, with the help of Griha, is trying to do. So, TERI has developed Griha with over 2 decades of experience on green and energy efficient buildings, and in 2007 it was also adopted by the government of India. Internationally also, many voluntary rating systems are instrumental in mainstreaming this sustainable habitats by raising awareness and also popularizing green design into the construction sector or building sector. But as I said earlier also, that different rating system, they pertain to their own countries or their own city, or to the larger global platform. So it was important that uh, a specific rating system be created which can cater to the needs of Indian habitats as well. So Griha is a very uh, key rating system which has been developed to facilitate the same. So it is a uh, the Griha pre-certification. It has also been accepted by uh, Ministry of Environment and Forest for to fast track environmental clearance. So Ministry of Environment and Forest, which is now MOEFCCC, which you might know. It basically provides environmental clearances for many projects. So, any project which is having particular impact on the environment because of the project. So, the project requires specific environmental clearance before it can proceed, and that clearance is provided by the MOEF. So, if your project has a pre-certification by Griha, so the MOEF can provide a fast-track environmental clearance for your project, considering that it has a pre-certification from Griha, meaning that it follows the green green building or greenness criteria of sustainability. So that is there. Apart from that, GRIHA has also been internationally recognized. So it has been recognized by the United Nations as an innovative tool for sustainable development, and it has also been uh, uh, used for implementing renewable energy in the building sector by a project known as the Climate Reality Project. And it has also acted as a contributor to the UNEP SBCI, which is the Common Carbon Metric that has been developed by the UNEP. So the metric has been developed using different international and national building energy data collection or rating system. So from the data collected by different rating systems all over the world, the common carbon metric has been created, and uh, one such contributor of uh, the international building energy data collection was GRIHA. So GRIHA has contributed to that as well. So GRIHA is now uh, almost 2 decades old, or maybe even older. So it has followed a 2 decade long timeline to be what it is now. So it basically started in 2000 with Terry. Uh, Terry conducted over 100 building audits, and it used that study to construct a retreat, Terry retreat, or their building, following all the knowledge which was learned from the audit of these buildings, and it was constructed in a way that it focused on green building guidelines, or the building was constructed in a way that it could be called a green building. So the seed for this green building certification or green certification started from there. After that, uh, Terry released GRIHA Indigenous Green Building Rating of India in 2005, and then further in 2007, MNRE adopted GRIHA as a national rating system for green buildings. That year, ECBC code was also released in India, and later in 2008, the National Mission on Sustainable Habitat was launched, which also took into account this GRIHA rating system. Then in 2009, the Committee of Secretaries, uh, the Committee of Secretary mandated that 3-star GRIHA rating should be mandatory for all government buildings. So any government building which is being planned to be constructed, it should mandatorily have a 3-star GRIHA rating. In 2009, even the CPWD adopted GRIHA rating, and in the same year, it was acknowledged by the United Nations as well as an innovative tool for sustainable building design. Then in 2010, the Evaluators and Trainers program by GRIHA was launched. So it then further helped GRIHA, or the sustainability rating system, to get more mainstreamed into the building and construction sector, as more evaluators and trainers uh, will become a part of this rating system. Then in 2011, the GRIHA was adopted by PCMC. PCMC is the municipal corporation for Pimpri Chinchwad. And what the municipal corporation did is that it provided premium discounts to all the developers and property to all the developers for property tax rebate, and for buyers it announced in PCMC that GRIHA rated project will have tax rebates if the projects have GRIHA ratings. So this was a way of PCMC to provide incentive to people that they get their buildings GRIHA certified, buildings or project GRIHA certified, and have and build the buildings or projects in a way that they are more green. Then uh, in the same year, the Committee of Secretary also recommended upscaling of GRIHA, and following that, Adarsh and CREDAI. So CREDAI is a apex body of uh, real estate developers in India. They signed an MOU, and as a part of that MOU, they decided to further GRIHA, or the importance of GRIHA, to all their real estate projects, and uh, uh, they focused on incentivizing the adoption of GRIHA into all the different real estate projects that they were dealing. Then in 2012, Swagriha was also launched. So the Swagriha, which I just mentioned, which is a self-evaluation checklist. It so earlier all the uh, ratings, or all the GRIHA rating was largely for buildings or projects which were larger than 2,500 square kilometers. So it was not really applicable to smaller projects, or it did not make sense to evaluate smaller projects for uh, using GRIHA. But after 2012, Swagriha was launched, and even smaller project could then be evaluated using this. Uh, then Griha project catalog was also launched, and guidelines for large development, even larger development, was also launched. I'm sorry, just give me one moment. Okay, coming back. Okay. Then in 2019, the Griha LD rating for large development was also launched, and another app was also launched for Android, uh, and it provided more user-friendly way for interacting with the rating, and uh, a new website was also launched for Griha. Uh, the same year, Kriya was adopted in for FAR incentive generation for in Noida and Greater Noida. Then in 2014, Griha Prakriti rating was introduced for day schools, and an app for iOS was also launched, and even MOUD uh, provided incentives based on GRIHA rating for FAR in different projects. And then an MOU was also signed between USGBC and USGBC and TERI for furthering of GRIHA rating, and even the state of Sikkim adopted GRIHA in 2014. Then moving on further, in 2015, GRIHA and GRIHA LD 2015 version were launched, and the government of West Bengal also adopted GRIHA for their municipal affairs. And even further FAR incentives were provided by different governments, like governments of Rajasthan and Municipal Corporation of Pune and Ahmedabad Urban Development Authority. Different authorities provided FAR incentives based on the GRIHA rating. So this is how GRIHA has been tried to, uh, the governments at different levels have tried to mainstream GRIHA into building sector in India, and leading up to 2019, where when the new and updated GRIHA rating has been introduced. So as I mentioned just now, that GRIHA follows different all the entire life cycle from the inception through the operation to the end stage of the building. So it focuses on the building evaluation in three stages. First is the pre-construction stage. So intra and inter-site issues like proximity to public transport, then the type of soil of the site, the kind of land where the property is located. So things like the flora and fauna and the climate of the place, all the factors that are taken into consideration before the construction activity even starts. So these are the pre-construction stage considerations. Then the building planning and construction stage. So issues of resource conservation related to the land management or even other things. So resource conservation in terms of the resources being used to build the habitat or the project. Then reduction in resource demand and proper resource utilization, so making it more efficient. And then resource recovery and reuse, and then provision for health and well-being of the occupants. All such things are taken into consideration during the planning and construction stages. And then comes the building operation and maintenance stage. So all the issues of operation and maintenance of the building. So the building systems and processes, monitoring and recording of energy consumption and occupant health and well-being, all such things are covered under the operation and maintenance stage. So GRIHA provides many benefits. On broader scale, we know that its two main goals. First goal is reducing resource consumption and greenhouse gas emission, and the second goal is uh, introducing more renewable energy sources or more renewable uh, energy usage into building sector. That is on the broader scale on the benefits of GRIHA, but there are several other benefits of green design or green buildings as well, both to not only to the community or society at large, but even to the building owner and the user of the building. So these include reduced energy consumption without sacrificing the comfort level of the occupants, then reduced destruction of natural areas of ecosystem habitats and biodiversity, and reduced soil loss from erosion, etc. And then reduced air and water pollution with direct health benefits, reduced water consumption, limited waste generation due to incorporating things like recycling and reuse of wastes, and then reduced pollution loads due to any project, and then increased user productivity, and then enhanced image and marketability. So as I said, as I showed you just now, when we were seeing the evolution of uh, uh, GRIHA over the period, you saw that a lot of the municipal corporations and even state governments provided specific benefits or FAR incentives based on GRIHA ratings, and even the United Nations considered it as an innovative tool, and uh, the Ministry of Environment and Forest also provides fast track clearance for environmental clearances if your project is GRIHA rated or green rated. So basically, GRIHA rating, or your project, if it has been rated with this sort of green building rating, the image and marketability of the project also increases. So this is one more benefit of Griha which is there. So I hope the background of Griha is clear, and we can move on to our question now. So coming back to the question again, the question was basically to analyze and score your residence as per the Griha guidelines. So this is the link that was provided uh, in the question. So this link basically takes you to the Griha checklists which are there on their website. And as you can see, there is a checklist for affordable housing, for existing buildings. There are feasibility checklists as well. So the latest one, 2019 one, and the older one. Then there are self-evaluation checklists. Then checklists for day schools and for larger developments. And this is for Griha, which is the self-evaluation checklist, and then Griha for cities. So this is a city self-evaluation checklist. So because we are doing a small project for this example, we are not doing a larger project, so we will follow the Swagriha self-evaluation checklist as we just saw. That Swagriha self-evaluation checklist was introduced for projects which had a smaller built-up area or smaller site area compared to other projects. So if you click this link, an Excel sheet will be downloaded which contains the checklist. I'm sorry, there is some problem, I think, with my Excel. It is not opening. Uh, no worries. I already downloaded this earlier, so we can just refer this checklist instead. So basically, this is what the checklist will look like. So I hope everyone can see. So a checklist like this with the Swagriha evaluation tool will be downloaded for you, and it will have these different criteria, and for every criteria the maximum points that can be awarded will be given, and category wise, then category wise point distribution will also be given for you, and for each criteria, uh, what is uh, what is to be measured and how it is to be measured will be given. apart from this, another thing which you need is the Griha manuals. So I'll be sharing this Excel sheet with you, and I think it is already uh, uploaded on uh, the shared folder. So you can uh, check that in your own time. But for now, let me just show you. So this is the link for the Griha manuals which I have provided here. So if you just go on to the link, you will see different manuals which are there. So like the manual for affordable housing, the existing building manual, or the day school manual, and all such manuals are there. So we are working with the Swagriha evaluation. So we'll open that manual for now. So this is the Swagriha manual. As you can see, it provides you details about uh, different criteria of the rating system. You can see different criteria, how much point each criteria uh, contains, so the point distribution, and then further how much points will give you water rating, and then it explains each of the criteria in detail, what you need to consider for each part of the criteria, how you need to make the calculations related to each component. So I hope that is clear. Coming back to our evaluation tool. So this is the example which I will be considering to explain to you this evaluation tool, or how it can be used. So I have taken just a uh, just an example of a residential building. So you can see this residential building which is located on this site, and this is the building, and this is the paved area uh, around the building, and the vegetation uh, on on the land or on the site. So the building is located in Allahabad. It has a site area of 200 square meter with a building footprint of 100 square meter. Apart from that, there is a paved area on the site of 25 square meters, and the built-up area of the building is 200 square meters. So the building also have a number of mature trees on the site before construction, uh, uh, which all have been protected after during the construction of the building. So the number of mature trees before construction were 10, and all 10 of them have been protected. Then there are some details about the area of fenestration on different facades of the building, and this building is for 6 residents, so the occupant number of the building is 6, and the building also has an installed capacity for solar water heater for 500 liters. So this is the example we are considering for our study. So let's start from the top. So first criteria is reduction of UHIE and maintaining native vegetation cover on the site. So UHIE is urban heat island effect, and this criteria focuses on reducing the urban heat island and maintaining the native vegetation over the site. So first uh, component in this is that 50% or more of the total paved area on the site will be soft or shaded or coated with a finish of SRI less than 0.5. So coming back to here, we can see here that our paved area is 25 square meter, and we can see some of that is shaded, like for example the area for parking is shaded. However, we don't have any soft paved areas. All of these pavings are hard pavings. So we know here now that what our pavings are. So you can see here, like I have written, our total paved area is 25 meters, of which 0 meter square, 25 meter square is the paved area, of which 0 meter square is soft, and 10 meter square, which is the parking, is shaded. And our total site area is 200 square meters. And then comes the compliance calculation. So for this, we can go back to the manual. So you can see here. So part 1, which is the reduction of exposed hard paved surface on the site, and this again has the same criteria, that this is the calculation for the compliance, that total soft paved area plus hard paved area divided by the total paved area should be greater than 50%. That means the ratio of the soft paved area and hard paved area, which is under shade, compared to the total paved area on the site, it should be greater than 50%, which means more than half of the paved area on the site should be either soft, or it should be under shade. So we can see again from here, we'll make this calculation. So if you can see the formula here, our formula is soft paved area, which is O5. You can see this is O5. So soft paved area plus hard paved area, that is shaded. So O6, O5 plus O6, which is divided by O4, which is the total O4 is this, which is the total paved area. So this comes out to be 0.4, and 0.4, which is 40%. 0.4 can also be seen as 40%. So this comes out to be 40%. So the total soft paved area and shaded paved area is only 40% of the total paved area on the site. So seeing this rating, it is not 40% or 50% or more, it is only 40%. So we do not get these points. So if we wanted to make our building more green, or we wanted to get the points for greenness here, what we can do instead is take some part of our building here, take some part of the pavings which are existing here, and instead of making them hard paved surfaces, we can make them soft paved surfaces. So for example, if we want, we can, out of the 25 meter square, we know that 10 is hard paved but shaded, and the other we can, other 15 of that, if we can make 5 square meters, if we can make them as make that as soft pavings, our compliance calculation comes to 0.6, and then it becomes more than 50% of the total paved area. So if we fulfill that, if our building fulfills that, we can give us 2 points for this specific criteria. Then the next is if there are existing mature trees on the site. Yes, there are 10 existing mature trees on the site. Uh, are all mature trees in the perimeter zones being protected? So we can just give ourselves 1 point here because we have protected all trees no matter where they lie on our site. But if you were to cut some trees which did not uh, uh, off on your side, so you need to see again that if those trees lie on the perimeter of your site, or it lies within your site. So for different position of the tree, there are different criteria for evaluation. So it is important to see how they define the perimeter, so you can judge if the tree is lying on the perimeter of your building or is it lying within your site. So you can see from here they have provided that demarcate the periphery zone uh, as per the local building bylaws, or you can demarcate the periphery as 2 meters from the side boundary. So if you just take 2 meter offset from the side boundary, you will get the periphery of your site, and then you will know which trees lie within the perimeter or the periphery zone, and which lie within your site. So all the trees which lie in the periphery zone, they should be protected in order for you to uh, get this 1 point. So because we have protected all the trees, we are giving ourselves 1 point for this. The next is the total number of mature trees on the site before and after construction are the same. This also is yes, because before and after construction we are not cut any of the trees. We have retained all of the trees which were there before the construction, so we can give 2 points for that as well. Then next is all new trees being planted on the site are native to the region. So we will give ourselves 0 here because we have not planted any new trees on our site. Then this is the criteria that no mature trees exist on the site, so we can just leave that because our site has mature trees. Another thing which you can pay attention to, that if your building or your project has if you have cut some trees on your site, they have guidelines so that you can plant more trees than what you have cut, and then you can again get more points for being green in your project for that. So you can see here they have mentioned that plan your landscape plan such that you plant as many trees that you have cut, and the trees should be of the same species as cut or native species. So even if because of project concerns you are forced to cut some of the trees on your site, what you can do instead is that you can plant more trees which are of the same species as the ones you have cut, or of the species which are native to that area. So that again can help you better your green ratings. So how to, then the question comes, how to see which species are actually native to your area. So for that you can follow some uh, trusted guidelines or trusted sources of what vegetation is native to which area, and then you can take those guidelines, and you can see which trees can be planted on your site. So for that I have provided a reference to you. So this is the link to the National Atlas and Thematic Mapping Organization, or NATMO, which you might know. So this is these are their maps for natural vegetation in India. So you can see here. This is a map of India showing natural vegetation. And you can see which kind of vegetation exists in which area. Similarly, you can even see these kinds of maps. So you won't probably get very accurate estimates for each city, but for larger cities you can get an estimate from this kind of map as well. So you can see what kind of tropical or subtropical or evergreen, which kind of vegetation is native to which area, and accordingly you can then make choices. So you can see which are the tree species which belong to the uh, uh, specific vegetation type. So, for example, if we are planting for Allahabad or Allahabad, which is in Uttar Pradesh, will look for uh, so this is 2A. So 2A is tropical moist deciduous forest. So or tropical deciduous vegetation. So we look for trees which fall into this category or fall into a native species belong to this type of vegetation, and then we can select the appropriate species which are suitable for planting in Allahabad based on this type of vegetation. Similarly, you can find the forest types for specific parts of India as well. So for central India or western India. So for example, you can see this is for central India. You can see there this has been divided into tropical semi-evergreen forest, tropical moist deciduous forest, littoral and swamp forest, tropical dry deciduous forest, thorn forests, and broad-leaved hill forests. So you can just zoom into it, and you can even see uh, cities and smaller towns you can find here, and you can see which kind of forest or vegetation is native to that area. I hope that is clear. So you can just click on this link and you can see there are forest types for southern India, northern India, western India, eastern India, for mangroves. All of these resources you can access if you want to find the native species belonging to the location in which your project lies. Uh, so this is okay for us. So our total points for criteria 1 is 5. So we got 2 for this, 2 for our pavements, 1 point for the mature trees at the perimeter, and 2 more points for retaining all the mature trees in our site. So out of 6, we got 5 points because we are not planting any more trees, so we lost 1 point. Okay. So you saw here also. So the highest category was point which we can get here is 6, and the minimum points which need to be attempted in this category to uh, get the certification is 3, and we have gotten 5. So this way the points get logged into each category. Then the second criteria is passive architectural design systems. So let's go back to uh, the manual. So you can see here, based on the site area also, they have defined how many fully grown mature trees are to be planted on the site for you to get the extra point in the certification. So if your site is less than 250 square kilometers, you need to plant two more trees. If it lies somewhere between 250 and 750 square meter, you need to plant three more trees. And if it is a site area greater than 750 square kilometer, you need to plant three plus one tree. So plus one is for every extra 250 square kilometer that is there in your site. Okay. There are several other criteria which you can see here, which pertains to your specific residence which you are evaluating. I am evaluating for my residence, and because we have not planted any more trees, so I have just left this. If you want to plant more trees, or your case involves something which includes planting more trees, you can further uh, read this description, or read how you can evaluate that. Next is next criteria is adoption of passive architectural design strategies in your building. So you can see here there are two categories here. First is two passive strategies from those given in the list. Those given in the list that have been adopted in our design. And then first is two passive strategies, and the next is active low energy heating or cooling system that have been installed in the building. So let's go back. So example of low energy or passive heating cooling measures. These includes things like desert coolers and fans, earth air tunnels, passive downdraft evaporative cooling systems, direct and indirect evaporative cooling, solarium, and Trombay one. So in case of my example here, you can see uh, there is a water body uh, in the back of the building. So this water body and the vegetation surrounding it contributes to passive evaporative cooling. So uh, among these categories, uh, indirect evaporative cooling is the one which has been incorporated in the design of my example. Apart from that, desert coolers and fans are also part of the building, so these have been employed in the building. So again, two of these low energy or passive heating cooling measures have been incorporated in my building. So I think my building or my example uh, qualifies for this active low energy heating cooling system points. So I am awarding 2 points for that, and then two passive strategies. So going back again, now we see this passive strategies, passive design measures. They are based on the different climate your building lies in. So there is composite climate, there is cold, there are techniques for warm and humid climate, for moderate, hot and dry, etc. So to actually find out if I can award myself points or not, I first have to see which climate building lies in, and if it is following the specific passive strategies for that specific climate or not. So in order to see which climate my building lies in, we have to first follow a national guideline to see which climate uh, my building lies in. So for that, we'll follow the ECBC, or Energy Conservation Building Code. This also you would have studied in this week. So we'll just go to annexure E. Okay, it's appendix E. So appendix E is the climate zone map of India, or it defines the climate zones which are there in India. So okay, we have reached it. So this is the appendix E of the ECBC. So it is a climate zone map of India. So if you want to find your city here in the climate zones, or if you can find your city here on the map, you can accordingly see the corresponding climate zone where your city lies, and you can select the climate zone based on that. Another thing which you can do is that if your study or your project lies in a major city, the climate zone of major cities have been listed down in this table as well. So we are doing Allahabad. So you can see from here, Allahabad lies in the composite climate zone. So the climate zone for our example is composite. So coming back, we need to see if our building incorporates some of the passive techniques which are suitable for the composite zone or not. So you can see the different techniques for composite zone. So first is solar chimney or wind tower. No, our case doesn't have that. Courtyard also no. Water bodies for evaporation, yes, our building has that. Reduced solar access. Uh, this also you can see that our building has a lot of large shading devices. So these are shades which have been extended so that the building gets reduced solar intake. And this is there on the south side. You can see this is the building's north. It is there in the south and the east side. So it is important to shade the west and south side of the building. So west is not very shaded, but the south side of the building is properly shaded. So we can still consider that yes, there is some reduced solar access. Then is the building or site planned in a way to increase cross ventilation or layout from windows, etc. Sorry, just give me 1 moment. Okay. Coming back. Okay, so there is no specific planning on our side for increased cross ventilation, so we can disregard that. Also, our site doesn't have any earth burning or thermal mass to reduce heat gain or heat loss. We have some vegetation, but we don't have dense vegetation to moderate the microclimate. So no, we cannot say that also. We also do not have any cavity walls or green roof. We also don't have any roof insulation. There are no slopes on our site. It is a flat lying site. so we can't consider that even. And none of these also have been provided, although we have a pond or uh, water body for evaporation which is there. So this we can say that is the only passive cooling or passive design technique which is there, apart from reduced solar access on the south side of the building. So seeing this, I think we can award 2 points here as well. Coming down to the next, which is good fenestration design for reducing direct heat gain and glare while maximizing daylight penetration. So for this, you need to calculate first of all your fenestration design and what overall insulation that is being gained by the building, and they have provided specific way of how this is to be calculated. So you can also see here for the different commitments you make, or the different design commitment for green building design which you make in your self-evaluation, the different compliance documents which you'll need to submit as a part of this compliance report to get your rating have also been mentioned in this document. So for example, for getting this passive design technique, what you'll have to submit is architectural drawings related to the key passive design measure and active low energy cooling heating system that have been adopted in the building. So the fan and desert cooler, and the evaporative passive evaporation pond which is there, and the shading devices which have been incorporated in the building as a method of passive cooling or heating technique. The specific architectural drawing of those elements have to be submitted as compliance documents to get this rating. It can even be sketches which highlight the adoption of passive design measures and active low energy cooling or heating system. Next is the fenestration design, which we were just considering. So they ask to calculate different things like the insulation based on the design case and the base case. So in the design case, you enter the total window area on each facade, and according to the orientation of the facade, and this helps to calculate the total direct insulation on the building through the insulation. And this is then compared with the base case, in which so this is what your building actually has, and the base case is that all of the facades have equal amount of fenestration, and then your design case is compared to the base case, and then it is evaluated that compared to the base case how much direct heat gain is coming through your fenestration, and if heat reduction is taking place in case of a building which lies in a composite or hot climate, or more heat gain is taking place in case of a building which lies in an area of cold climate. So similarly, guidelines are provided for making these calculations. Apart from that, even calculation for daylight which your building is getting are also provided. So direct heat gain through insulation, window area, shading coefficient, etc. is also provided, and they have also provided daylight factor percent of each of the dwelling area. So based on this, you can see which of your dwelling areas lie for that. So because we are focusing on residences, this will be the daylight factor percentage which we will be considering. So If you want to see how what these calculations are based on, I have linked several studies. For example, this is a white paper for fenestration studies. Nirali is asking where you can find this PPT. Nirali, all of the presentations and all of the material which I share in this in this live session, these will be made available to you on a shared drive folder, and link to the drive folder, it will be shared with you on the NPTEL website. So when you log in, you will be where you get shared all the course content. There itself, the link to the shared folder will also be there. So you can see all this material from that link only. Okay, so for example, this is understanding fenestration. It is a white paper, so it tells you how complex glazing system works and what are the different methods of measurement and calculation of, for example, insulation or illuminance in the building and different things. It also mentions several standards which you can follow to see how much uh, thermal transmittance or uh, daylight your building is getting. Similarly, there is this ISO standard. So this is the ISO standard for energy performance of fenestration system of residential building. So it details out the calculation procedure of how different things like solar radiation or fenestration energy performance, etc. can be calculated. Although uh, this is a paid thing. This is not free of cost. So uh, to access this guideline, you need to buy, unless your organization has already a subscription to this content. Then you can access this content through your organization. Apart from that, there are even daylight zone codes. So, for example, this is for side light spaces. So, there are energy code standards and guidelines for daylight and things. So, you can check that for these calculations. Then there is Terry's guideline for daylighting prescription as well. So, this is Terry's daylighting prescription for affordable housing in India. And these you can use to actually study how these calculations are made, what factors are considered when you calculate fenestration design or daylight which is there, or over insulation which the building is getting due to the particular fenestration in your building. Apart from that, there are even visualizing softwares which you can use. You can just enter your data, you can just enter your plan, and you can visualize how uh, daylight and solar insolation and illuminance, such things are there for your building in your particular climate. So, for example, this is one type example of one visualizing software. It's called Velux Daylight Visualizer. So it is a free software both for Mac and Windows, and it can provide simulations for daylighting and solar insolence in your building. So such kinds of things also you can use. Uh, However, in the case of this Swagriya evaluation tool, so this uh, this calculation, this the manual asks you to make this calculation on your own. However, in their uh, uh, certification uh, tool which they have, you can directly enter uh, the details about location of your building, the climate, and the area of fenestration on your each wall, and details about your plan, and it will make these calculations on its own. So I won't be going into the details of how these calculations are made, or neither there is time for making the detailed calculation about these, but I hope I have provided you enough resources that you can make these calculations for your building. For now, I'll just uh, give arbitrary uh, scores for the sake of this exercise. So we have given 2 for fenestration design and 1 for daylight. So we have gotten 3 out of 6. The next question is if there is efficient artificial lighting system. So we can say yes. So there are different techniques of efficient artificial lighting system. So for example, there can be light sensitive or motion sensitive sensors which can be installed so that lights get on and off on their own when not in use. So for example, we consider that our building has such artificial lighting system which have been installed, so we can say yes, they have been installed. So uh, moving on to the next point, which is thermal efficiency of the building envelope. I know, I think you already know what a building envelope is. It has been discussed several times in the previous lectures. So this criteria, what it basically asks to see is the thermal efficiency of building envelope. Uh, if it meets the threshold that has been prescribed first in the Swagriya thing. So seeing this again, okay. So these are the appraisal points that have been prescribed for major cities, and then you can see there are points for different types of building, like for residential and commercial. You can see it tells you how to analyze different criteria. So you can see if your building has if for fenestration or some treatment of facade of the building has glass, so you have to take the SHGC of the glass into account, or U value of glass walls or roof or things like that, to then calculate the external heat gain into the building. And then to calculate the internal heat gain, you need to consider how many residents are there in the buildings, or the building occupancy, and then uh, the lighting system which generates lesser heat, or things like the equipment power density. So how many equipments are there, and what amount of heat they are generating. So these things can be used to evaluate the thermal efficiency of the building. So I have again provided you a link to see how thermal efficiency calculations for building are made. Again, there exist softwares for this which can help you do this, and even the tool for Griha, you can just enter the details about your building, and it can calculate this for you. But if you want to see the background information on how the energy efficiency of your building or building envelope is calculated, or what goes into the background of calculation. For example, considering the U values of different elements of uh, the building envelope, you can see those calculations and things here. So based on this also, you can either make those calculation, or see uh, that for yourself, and award points to your building accordingly. I'll just award 2 here. Uh, then use of energy efficient appliances. So for example, air conditioner, fan, geyser, water pumps, etc. Are they BEE 3-star labeled, or 4-star labeled, or 5-star labeled? According to this, you can see appliances in your building, and you can award points for that also. So I'll award 2 points here. Then if you are using renewable energy on your site, so I'll just say no and award 0 points here, or I won't award any points here, because you can see in the case of our building, we have a capacity for solar water heater. So we have a solar water heater, but we are not generating any other energy which is being used by the building. So we are generating hot water for building usage, but no other energy for other building usages being generated on the site. So for this, we'll just award ourselves 0, because there is no use of renewable energy on the site which is happening. Oh, I'm sorry. Actually, solar water heater is a part of this only. So I'm sorry about that. Now let's see the calculation for solar water heater. So what they say, that the installed capacity of solar water heater, either is it 50% of your daily hot water requirement, or 75% of your daily hot water requirement. Accordingly, you can award yourself points. So let's see here. So you can see here, if your site or your project has a renewable energy system which is installed, you can see from here that what is the minimum size of renewable energy system which needs to be installed on in your project or in your building, to be counted as to be counted for a point in the certification. So you can see, if your building is 100 to 500 square meters, you need minimum 1 kilowatt of energy production installation. And similarly, moving on to the larger system, you need larger energy output. For solar water heater, you can see based on the different type of the building, you need different amounts of water, uh, different quantities of water per day. So because we are seeing here a residential building, we'll see this, which is 100 liters per day, and we'll make our calculations accordingly. So what it says is that ensure that 50% of the daily hot water requirement is met through the solar water heater, and or 70%, and the uh, so this is what is required. So let's go back to our calculations and see here. The number of our residents is 6 as we mentioned, and hot water per day per resident requirement is 100 liters. So this is 100 liter per day. So total water requirement per day will be 600 liters, and therefore we need, and coming back to our building, we can see here that 500 liter capacity of a solar water heater has been installed on in the case of our building. So you can see the capacity which is installed in our case is 500. So now we can make the percentage calculation, that how much percentage of total hot water requirement is being fulfilled by this. So you can see here L42, which is this, divided by L41, which is the total requirement. We are calculating the percentage for this, and based on that we can see that more than 83% of daily hot water requirement is being fulfilled by the solar water heater which is installed in the building. So we can give ourselves 2 points here, because more than 75% of the daily hot water requirement is being fulfilled by the solar water heater which is installed in our building. Okay, so uh, you can see in the uh, passive architectural design and system, which is for the second criteria, we got 15 points, in which maximum number of points you can get is 21 and minimum required are 11. Moving on to the next one, this is reduction in building landscape water demand. So this again makes calculation based on a base case, and then how much you have reduced based on the base case. So if we see here, these calculations are made on uh, considering one base case with normal or base case fixtures, and then seeing that if your building uses low flow fixtures which can reduce water use demand in a building, and then if your building has such fixtures, how many fixtures are there and how much uh, building water use or water demand it has reduced compared to the base case, and such calculations you can make based on that. And this is done for both. First is building water demand, so water within the building, so water being used by the users or occupants of the building, and then reduction in landscape water demand, so for the landscaping in your building, so the plants and everything which are there, the water which is required for that. So low flow fixtures can be used for both of them, and accordingly calculations can be made. I have provided several links. So for example, this is linked to Leeds water use reduction calculation using low flow water fixtures. So this is actually sort of a toolkit, Excel based toolkit. I am not sure, my Excel is not working, so this will not open. But this is basically an Excel based toolkit which you can download from this website, and you can use that to make your calculations uh, for water use reduction by the use of low flow fixtures. Similarly, there is a study for indoor water efficiency. You can refer to this study as well. So it tells you about different fittings or fixtures, and it gives you a baseline, and then it helps you calculate how water use reduction can be done based on different types of fitting and fixtures. So for kitchen, for toilets and everything, it provides you different details. So if you want to learn more about how those calculations are made, you can visit these links. I won't be going into the detailed calculation of this. So for this, I'll just give arbitrary points. Okay. And this then uh, rainwater harvesting. The next criteria is rainwater harvesting. So rainwater harvesting, uh, our building is located in Allahabad. So first you have to see the rainfall data. If uh, your site is even feasible uh, for installation of a rainwater harvesting system. So matlab, does the dimension of your building or the amount of rainfall harvesting your building will do, is it even feasible to be installed in your building or not? So for this you need rainfall data of your of the location wherever your building is located. So I have provided a link to Indian Meteorological Department's report on rainfall statistics of India. So from here you can get averages, monthly averages or annual averages of rainfall in different cities and districts. This district-wise seasonal and annual rainfall statistics. From here you can get the data, and you can similarly find out the specifics of rainfall in your area, and then you can make the rainwater harvesting calculations for that. So for example, here we know that we have 6 residents, and if you see, not hot water, this is just water requirement per resident per day is 140 LPCD, which you might know. And this has been mentioned in the manual as well. So your rainwater harvesting system, it should be able to store water for 2 days of your requirement. So this calculates multiplying by 2 times the water requirement for 6 residents. So it is L53 into L54 into 2. So this is the total requirement for 2 days. And then we have our daily average rainfall in meters. So you might get details from IMD in terms in mm. So you have to convert in meters to make this calculation, and then you can get runoff coefficient. So uh, to make the calculation of rainwater harvesting capacity, you also need runoff coefficients. So I have provided a link to that also. So this is a link which gives you the runoff coefficient of different surface materials. So pavement, asphalt, concrete, brick, roofs, etc. There are different things. So we are taking roof. So we are taking the runoff coefficient as 0.9, 0.95. So concrete roof runoff coefficient, we have taken that, and we have calculated the rainwater harvesting capacity based on that. And so we will multiply the daily average rainfall and the runoff coefficient and the total area of the roof. So our total area of the roof is same as the building footprint, which is 100 meter square. So we have multiplied L7 by that, and we have calculated the rainwater harvesting capacity. So you can see the rainwater harvesting capacity of for our building is very low because annual averages for rainfall, annual rainfall averages or daily rainfall averages in Allahabad are very low. So rainwater harvesting system for our site for the small scale residential building which we have, it is not feasible. So for this we cannot install any points. We cannot award any points for this because the rainwater harvesting capacity is very less. Then generating resource from waste. So are measures being taken on site to convert organic waste to resource? So this you can see if your site has vermicomposting or similar things. You can say yes to this and award yourself points. There are even guidelines for that. For example, you see here for different buildings, the manual provides how much LPCD you need for rainwater harvesting. And you can see here for generating waste, something from waste. So if you are converting organic waste into manure or biogas on site, so this is not suitable for residential building, but if you have a larger industrial or different kind of building, that it can be possible. Or if you have vermicomposting, so we said yes, we have vermicomposting, and we awarded ourselves 2 points for that. Then it talks about reducing embodied energy of the building. So I have provided a link of how embodied energy calculations are made for buildings. So it largely focuses on low carbon buildings. So embodied energy focuses on total low carbon materials in building. You can see here as well the calculation for reducing. First thing which is considers is that instead of using OPC or ordinary Portland cement, if you use PPC in your building construction, which is Pozzolana Portland cement. This is made of fly ash, which is mixed with cement, and it is low carbon as compared to ordinary Portland cement. So if your building has that, you can award yourself 2 points. For the sake of this exercise, I'll say that our building has been constructed with PPC instead of OPC, and we will award ourselves 2 points. And then again you have to make calculations that if you have used materials which reduce the embodied energy of your building compared to the normal material. For example, here we used PPC instead of OPC, so we have reduced 100% uh, 100% of the concrete, the embodied energy in terms of concrete. So we have given ourselves 2 points. You can do the same calculations for the wall panels, the slabs and things, as you can see here. So these are the calculations which you can make. So embodied energy for low energy slabs or area remaining under the slabs, and then compare it against conventional RCC slabs and conventional wall, or compare them to low energy walling, and similar calculations you can make, and you can see how much embodied energy you are reducing in your building. So such calculations you can make. I have provided this link. If you want to see in detail how these calculations are made, you can visit this link. Then use of low energy materials in the interior. So in interior also, if flooring is low energy or not, if your paints are low VOC and lead free, so you can see what kinds of paint you're using, and in the specification of your materials which are used, you can see if they are low energy or not. In most cases, when you purchase building material, or when you buy building material for building construction, the company who manufactures the building material, they provide information if the building information about the embodied energy of the building material that you are using. So similarly, you can make calculations for these as well. And then there are things like adoption of green lifestyle. So does built up area per capita meets the Swagriha threshold or not? So what is the Swagriha threshold? So this is the Swagriha threshold, that it focuses on that it focuses on equitable distribution of resources. So the amount of built up area you are consuming, it should not be too little that you don't have a good livable space, and it shouldn't be too much also that you are consuming too much of the resources and it is then not available for other people. So for example, in case of residential building, the built up area per capita or per resident, it should be more than 12.5 square meter, and it should be less than 50 square meter. So let's see our case. In our case, we can see we have a total of 6 residents, and we have a total built up of 200. So we'll just divide our total built up by residents, which is 200 by 6. So we get 33.33 square meter, which is less than 50 and more than 12.5. So yes, we qualify for Swagriha's threshold, and we have uh, optimum per capita built up. So then there are things like, is your building located in an area that expected distance that it meets the Swagriha threshold. So let's again see. So if it is a residential area, 2100 kilometer per annum should be the amount that you need to travel every day for accessing your basic resources. So you can see, based on where your building is located and where your most common amenities are, how much you need to travel to access different resources, and based on that you can award yourself points. And then have you provided dedicated toilet and resting room for your service staff? Then do you have an organic farming or kitchen garden in your project or not? Similarly, you can award yourself points based on that. And then there are 2 more points if uh, innovative strategies are being employed, for which I'll award 0 because we have not provided any innovative strategies. So seeing from all, we can see that our building has received 34 points based on all our calculations. So we can see our building is can be certified as 2-star. It can be given a 2-star certification in terms of green buildings. I hope this is clear to you. All of this I'll share with you, and it will be available to you if you want to see it on your own and read further. All the links to different documents also will be shared with the PPT and the Excel sheet. So if you want to read further and get to know more about all these calculations related to green buildings and things, you can access those as well. I hope that was clear. That is all for today's session. If anyone has any questions, please go ahead and ask. I see Anand and Keerti. Do you have any questions? Please ask. Anand is asking if this recording session is available online. Yes, yes, Anand. All the recordings of the sessions are available online. They are available on YouTube, and the link to all these recordings will be shared with you. I don't know if you have already found the links or not, but if you log into the Swayam portal where you access all the resources for this lecture, you will also find a link to all the live sessions. So where you get the notification about the live session, there you will also find a link to the shared folder which has all these files, and the YouTube video which is a recording of this session, so you can access it there as well. I hope that is okay. Kirti said that she has no questions. Okay, Anand, do you have any more questions? Do you get any license to register in Griha? So Griha certifications you can register for your project to get a Griha certification. Uh, if you are asking about if you can be a consultant or if you can train to uh, file for Griha certifications. They have training programs also. You can visit their website and you can see they conduct training programs as well. So I have provided several links to their website. If you can just go and see on their website what training programs are available. I hope that is clear. Any more questions? Okay. So I think that is it for today then. Thank you very much for attending today's session. I hope it was helpful to you. If you have any more questions, you can reach out to me in the next session or on the forum, and you can get to your questions there. Feel free to access all the resources that I have provided, and I'll see you in the next session. Thank you so much for attending.